me. So our project is on Parkinson's disease detection. Firstly, we'll discuss about Parkinson's disease briefly. So Parkinson's disease is a neurological disease which has not recognized etiology. It is a well-known neurodegenerative disease after the Alzheimer's disease. Elderly group people are most commonly affected by this Parkinson's disease. So the symptoms that are observed in Parkinson's disease patients are tremors, bradykinesia, rigidity, postural instability, and voice impairment. Parkinson's disease does not have a diagnostic method that is completely accurate. Detection should be accurate because in this, if it is not accurate, it might lead to incorrect treatment and worsening of the patient's condition. The main objective of this project is to build a machine learning model that will provide the best accuracy in detecting the Parkinson's disease. The existing systems are made up of various algorithms or models such as linear regression and SVM, which use the dataset, which consists of acoustic features that are extracted from language tests, but which do not provide high accuracy as they do not work well with noisy data. This dataset consists of 24 columns. We'll discuss about the columns briefly. So first column is ASCII subject name and recording number, followed by second column discuss about the average vocal fundamental frequencies, and then third and fourth columns are maximum and minimum vocal fundamental frequencies, and then jitter percentage, jitter absolute, RAP, PPQ, DDP. These are several measures of variation in fundamental frequencies. And then shimmer decibel, shimmer AP, Q3, AP, Q5. These are all several measures of variation in amplitudes. And then NHR, HNR. These two features of ratio of noise to tonal component in the voice, and then the status. In this column, we have two values, 1 and 0. So 1 describes the person is having Parkinson, and 0 describes the person is healthy. And then the next two columns are two nonlinear dynamical complexity measures, and then signal fractional scaling exponent, and spreadsheet 1, 2, and PPE. These are three nonlinear measures of fundamental frequency variation. Implementation part. We need a dataset to perform a project. So we've taken a dataset for this project from UCI machine learning repository. The dataset consists of audible features which are extracted from speech recordings of different people and patients. This dataset has 195 samples and 24 features. After performing EDA, we found no missing values in this dataset. So firstly, we need to access the CSV file because the dataset first reads using the pandas libraries. Then the data is pre-processed by importing minmax scalar and using it. It is available through the scikit-learn library. The status column consists of the values 0 and 1. Healthy people with the value of 0 and Parkinson's patient with the value of 1. A minmax scalar is initialized. The features are scaled between the range 0 and 1 in order to perform a normalization on them. Here the dataset is divided into two parts. First part a train, and second part a test dataset. So 75% of the dataset indicates the training data, and the other 25% represents the testing data. The model is created in the next step, and it is trained with training data, and the training model then tests the test data to set up and make a prediction of its accuracy.
So as we have discussed previously in the implementation part, so we have built like various models over here. One of them is KNN, and then RF and XGBoost. So we have fed the data which is pre-processed, and we have scaled the data, and we have fed the data to these models. When we did so, we have received a 75.4% accuracy with k neighbors and 84.90% with random forest, and 83.01% with XGBoost. And on the right side of the slide, you can clearly see the KNN confusion heat map, where we have got like 18 of true negative values and 0 of false positive values, and 13 of false negative, and 22 of true positive values. When it comes to five-fold cross validation, when we have given the data to the five-fold cross validation, we have received 79% of logistic regression accuracy and 88.68% of random forest and 83.02% with the bagging. And when we model with the K neighbors and XG boost, we have received an accuracy of 81.13 and 83.02% respectively. And with decision tree we have received 79.25%, and with gradient boost we have got an accuracy of 90.57, and with ADA boost we have received an accuracy of 81.31%. And apart from these, we have also modeled an ensemble hybrid method where we have used ADA boost and XG boost as a layer 1 and KNN as layer 2. So with these we have received an 81.13% accuracy. So that's the end of the results part and the PPT part of the presentation. Now let's move to the coding part.
First step we need to do is to import all the required libraries. So we can see that I've imported all the required libraries. I've imported NumPy, Pandas, sklearn, XGBoost, and also I've imported SVC from sklearn.svm and some matrices from sklearn matrices, required matrices, and sklearn model selections to import grid search, SV and train test and split, and also sklearn pre-processing, XGBoost to import XGB classifiers, and also I've imported some classifiers required which are necessary classifiers from sklearn.ensemble. After importing all these libraries, the next step we need to do is to load the data set into the data frame using read as CVS which is imported from pandas. So you can see this is the data set which is loaded into data frame. After loading this, I'm checking the data types. You can see that all the data types of the each individual feature, it is in float and integer values in integer data types. And the next step is to describe. You can see that I've described the overall statistics of the data set and the mean, standard deviation, minimum, maximum, and again all the features. And the next step is the info of the data set. You can see that each so the basically mainly I've used this function to check whether there is a null values in the data set or not. So as you can see that there are no null values. There are 195 samples in each feature, but there are no null values in here. Everything is clear and followed by the data type. And the next step is to check the null values. There are no null values, which we have discussed earlier. Immediately the next step is to find the outliers. So first step is we need to find the outliers, detecting the outlier. So the next we need to we have plotted the outliers from the data set. You can see that we have some outliers here. So here there are no outliers, but we have many outliers in the other features. You can see there are no outliers here, but we have so many outliers. The next step we need to do is to remove the outliers. So we have removed the outliers. After removing the outliers, so this is the correlation. This is the correlation heat map. We have plotted a heat map using Seaborn libraries where we can see the correlation between features in the data set. And this, you can see that we have two labels of 1 and 0. 1 describes the person is having Parkinson, and 1 and 0. 1 describes the person having Parkinson disease, and 0 describes the person is not having Parkinson's disease. by running this we got two different values. That means it clearly says that the classes which we have are unbalanced. So we need to balance this data set. So what we have done is we we have used fit resample a method to resample all the data which is in the data set, to resample it and balance the data.
Part of the project. So here we are assigning data frame and the resampled labels and futures here, and we are gonna scale those futures and labels using minimax scalar, and here the futures are scaled and we are gonna assign labels over here, and we are using train test split function to split the data frame into test and train, where we are going to use the train data set to train the model and test the model using the test data set. So this part is same for all the models we are going to do now. So now let's go to the modeling part of the XtremeBoost. So here we are using XGB classifier function to build the model, and we are using the fit method to fit the model, and we are going to use predict function to predict the outcome of the trained model, and we are using accuracy score function to calculate the accuracy of the model. And these steps also will be same for almost all the models. So let's run this. So here we have got 88.67% accuracy for the XtremeBoost. Now let's see for the random forest. This is same as before. Here we have used random forest classifier function, and we are gonna fit the data now, and now fit the model, and now we are gonna predict and calculate the accuracy. So we have got 90.56% accuracy with the random forest. Now let's go with KNN. So in KNN we are gonna assign the data, scale the data and split it, and now we are gonna use PCA to transform it, and now we are going to build a KNN model using K-neighbors classifier function. We have predicted already, so now we are using confusion matrix and accuracy score. So we have got an accuracy score of 67.92, and now we are plotting the confusion matrix over here, and now we are going to plot a scatter plot to visualize the accuracy of each and every model. So now let's move to the 5-fold cross validation, where we are going to do as same as we have done before. We are going to assign the data, and we are going to use minimax scalar to scale the data, and split the data into train and test data sets. And now here using iterative kind of a code to run 5-fold cross validation on every model possible. Now let's run the 5-fold cross validation on each and every model. So with that we have got the accuracies are 62.26% and 90.57, 83.02, 70.47, 84.91. Everything we have got over here, and we have got maximum accuracy for bagging with 92.45. And now we are gonna plot a scatter plot for all those accuracies. Here you can see again got more accuracy. Now let's move to this ensemble hybrid method, where we are going to assign and split it, and here we are going to initialize the model using super learner function, and here we are adding the first layer with the ADA boost and extreme boost, and here going to be fit. So add the second layer, sorry, here it's KNN, and that fit the model and test the model. We have received an accuracy of 83.01%. So that's the coding part of the project. Thank you.